Okay, so you're watching this lesson. We are now into section 7.2, where we are going to learn how to first multiply and divide rational expressions, and then these will be simplified. Often what happens in this process is we try to do the factoring in the beginning much like we did in 7.1, and in the process of doing the factoring we will do a lot of simplification before we actually execute the multiplication or division. It simplifies the process overall and gives us a much more concise answer with less work. So to begin 7.2, we're going to take a look at multiplying rational expressions and see what type of work we can do to help simplify this process. We're going to begin by looking at question 15 from section 7.2, and it reads as follows. 3c divided by d squared multiplied by 8d over 6c to the third. When we began section 7.1, we had a monomial over a monomial and worked to simplify it in that way. Well, the procedure here is pretty similar. We're going to go ahead and take each part and break it down to its simplest components, as simple as we can get it, just to begin. So we're going to rewrite this over here. 3c, we can't write it any simpler than what it is. D squared, however, I can write it simply as d times d. Multiply by, well, 8 as we showed yesterday, this can be written as 2 times 2 times 2, and the d will just go ahead and write out once. And then 6, I can write 6 as 2 times 3, and then c to the third I can write as c times c times c. We now have each monomial and each four parts of the fractions broken down into its simplest factors. So now we look top to bottom to see which factors we can reduce. So for example, we have a 2 on the bottom and a 2 on the top. These can be reduced. We have a 3 at the top and a 3 at the bottom. These can be reduced. What we cannot do is we cannot reduce top to top. It always has to be top to bottom, because 2 divided by 2 is equal to 1, 3 divided by 3 is equal to 1. So in this simplification, we're helping to basically eliminate redundant work that would only be undone by division later. So now that we have no numbers to cancel, let's see if we have any variables. We have a c on the top here and a c at the bottom here. That will reduce. We have a d at the top here and a d at the bottom here. This will also reduce. Looking like it does not have anything else that can reduce, we'll take what's left. 2 times 2, that will give us 4. Here we have d times c times c. And we're trying to just put this in alphabetical order, so we're going to write this as c to the second times d, or just c to the second d, as we don't need to show the multiplication in between the variables. So we have our final answer of 4 over c squared d. So this will be the product of these two fractions multiplied together, written in simplest form. And when you express your answers when doing this type of work, your answers must always be expressed in simplest form. Let's continue. We're going on to question number 19 now, that will involve a little more work when it comes to factoring. And it's going to be written as follows. X squared minus 3x minus 10 divided by x minus 2 squared times x minus 2 over x minus 5. Now, taking a look at this, the first type of factoring one should always look for when you have a binomial or a trinomial or a polynomial with 4 terms is to factor the greatest common factor. In all 3 cases, we don't have a greatest common factor that will factor out of this. So we look for other ways we can possibly simplify this. Well, x minus 2, there's no factoring for this. X minus 5, there's no factoring for this. So we're going to rewrite that by keeping it exactly as it currently is. For x minus 2 to the second, Well, just like if we had 2 to the second, we could write it as 2 times 2. If we had x to the second, we write it as x times x. We can write the quantity of x minus 2 squared as x minus 2 times x minus 2, which is just another representation of the quantity of x minus 2 squared. When factoring trinomials, x squared minus 3x minus 10, this is a trinomial which can be factored into two binomials. Well, x times x will give us x squared, so we're going to begin the two binomials with x and x. We're looking now for two numbers whose product is negative 10 and whose sum or difference is negative 3. Well, the two numbers that traditionally give us 10 are 5 and 2. And 5 minus 2 is positive 3, so we're looking probably more like negative 5 plus 2. So we'll have here negative 5 plus 2. Negative 5 times a positive 2 will give us a product of negative 10. Negative 5 plus 2 will give us a sum of negative 3. So feel pretty confident now that we have the factors that we need to continue forward with carrying out this problem. So now that we have the factors, we should try to reduce where we can. And from what we see here, it looks like we have this x minus 5 reducing with this x minus 5. This x minus 2 reducing doesn't really matter. You could pick whichever one you want as long as you select one from the bottom. And all we have left on top is x plus 2, and on the bottom is x minus 2. So I can write my final answer as x plus 2 over x minus 2. You may keep the parentheses there. You may take them off. On some type of multiple choice test, you may notice that they're not there. That's perfectly fine. As long as there is not something else that is outside multiplying them, you do not have to keep the parentheses there. Okay, going forward, take a look at another problem that requires some mad factoring skills. We're going to take a look next at 23. This is going to be a to the second minus 9 over a to the second times 5a over a squared plus a minus 12. So in these problems, what you're going to typically see, especially when you take your test and you do your homework online, is you're going to see problems that you're going to have to multiply in these rational expressions, where there'll be multiple types of factoring that you'll have to do. So taking case for the top of the first fraction here, a squared minus 9, you should pretty readily recognize that this is the difference of perfect squares. And in factoring the difference of perfect squares, just like we discussed in the last lesson, we're going to take the square root of each part of the binomial. The square root of a squared is equal to a. The square root of 9 is equal to 3. And because it's the difference, I'm going to put it as plus and minus. A to the second, I'm simply going to write as a times a. So our first rational expression is factored. 5a, I can't simplify it any more than that, so I'm just going to leave it as is. But now we have the trinomial a squared plus a minus 12. This again is a trinomial that can be factored into two binomials. A squared is a times a, so I begin with that. But now I look for two numbers that have a product of negative 12 and have a difference of positive 1. Now, the 1 is not there for you to see, but if it's just plus a, they don't bother to put the 1. It's not necessary. If it helps you to put a 1 there, please go ahead and do so. So we're looking for two numbers that multiply to negative 12, but have a difference of 1. So because this is a negative product, we can assume that the signs here are going to be opposite each other. So what two numbers can we put here that will have a difference of 1? Positive 1, plus 4, and minus 3. So now we have both fractions completely factored. Now we see what we can reduce. So here we have a over a times a, and then we have 5 and an a over here, so these a's reduce. And for binomials, we have an a minus 3 here and an a minus 3 here. These also reduce. Let's take a look at what our final answer will be. Here we have a plus 3 times 5. Because we have something else on the outside, we need to to keep the parentheses around a plus 3. This is like the last problem, but in the last problem, we didn't have anything on the outside multiplying the binomial, so we did not need to keep the parentheses. Over here, we have in a times a plus 4. And from this work now, we have the product of these two fractions written in simplest form now.